Okay, hope everybody had a good 3-day weekend. It was a little cold 3-day weekend. We got the snow, but it was just a day late, unfortunately. But was a lot of fun if you got out in it. Focus activities will be due tomorrow. We're not going to have time for a fifth one. I wasn't able to put one together, so there's just 4 in the set. Many people have turned them in today. If you want to go ahead and do that, that's fine. In fact, that's great. If not, okay, make sure to have those with you tomorrow. We are going to go ahead and go over the test. Okay. But I want to go ahead and give you an overview of what's going to be happening before we go ahead and do so. By tomorrow, we should be able to finish up with our current lesson. Okay, and the plan is for Thursday, I'm going to go ahead and give you your homework assignment. This is going to be the last grade of the 6 weeks, in addition to the focus activities we're turning in tomorrow. That's going to be counted as a quiz grade. The homework's going to be due on Monday, so on Thursday, you're going to have time in class to work on the assignment, but at the same time, I'm going to be calling folks up to the computer one by one, and I'm going to be helping you figure out what your semester average is. Okay, because you're taking the final next Thursday. So for a lot of folks, final is probably not going to be too important to you. For some people, the final, you are dependent on it in order to pass the semester. Okay, so I got a review ready to go. In fact, you're going to get that on Friday. And I'm not going to be here on Friday because I'm going to be in the library all day taking care of something. But you'll have the homework to go ahead and take a look at. And if you're already done with that, then the substitute, he or she, whoever that is, will pass out the review. So you'll have, something to go ahead and work on Friday when I'm not here. And then Monday, we'll turn in the homework. We'll talk about it. But then we got to do something. It's always done at the end of the 6 weeks. District assessment, yes. We got to take care of the district assessment. So whatever time we have left on Monday, we'll go ahead and use for the district assessment. Then hopefully we'll finish it on Tuesday. Whatever time we have left on Tuesday and Wednesday, all that time will be devoted to the final, just answering questions on the review. So I've already talked to you about how I set that up. Okay, so there are 21 questions on the review. It's completely multiple choice. What I'm going to do is take 10 of those exact questions off of the review. That's your final. I'm not changing the questions. I'm not changing the answers. So if you work through the review and you feel pretty confident, you should already know exactly what the review final is before you take it. You just won't know exactly which questions. Okay. So kind of a little incentive there to look at the review. Hey, the test will be multiple choice. I mean, the number will be different, the number of the question, because I just chose them randomly. But the question itself, the answer choices, the order, everything will be the same. So basically, really all you got to do is just come in, hopefully take 5 minutes on that Thursday. I recognize this problem, and be done with it, and we're good to go. But there's always going to be a few people who kind of take time to solve the problems, and that's fine. You have the entire period. But that is our goal. That's how we're going to wrap up. Okay, any questions? No? Okay, what about the test? Was there anything on the test that we wanted to take a look at? Raphael, number 5. Okay, so it says tangent of sine inverse of 1 minus cosine inverse of 1/2. So we want to go ahead and simplify this inside first. So let's go ahead and start with sine inverse of 1. Now, a lot of people probably already know what's going to happen, but because it's positive, let's say we go in quadrant 1. And I'm going to use this grid down here. So I'm going to create my right triangle. Okay, so there's theta. Now, 1 is the same as 1 over 1, right? And sine is the opposite over the hypotenuse. So if these are the sides, then what's that x got to be? 1? No? It's going to have to be 0. Because 1 minus 1, they're going to cancel each other out, right? Yeah. So I can't have a triangle with these 3 sides. So we've seen this before. If I can't create a triangle, then it becomes a what? It's got to be a quadrantal. Now, sine inverse is restricted to quadrants 1 and 4. And we've got 3 quadrantals that are possible answers here. We have one that is 0, 1. We have this one here that's 1, 0. And we have this one here that's 0, -1. So remember, sine is just the y value. So now that we know it's a quadrantal, think of it like this. Which of these 3 locations has a y value that's 1? It's right here, 90. So let's say pi over 2. So sine inverse of 1 is pi over 2. Okay. Now let's go over to cosine inverse of 1/2. He's positive, so I'm going to put him in quadrant 1 as well. There's theta. Cosine, though, is adjacent over hypotenuse. So what would the height of the triangle be? Square root of 3. And we recognize this is what type of triangle? It is a 30, 60, 90. But what's across from the square root of 3? It is 60. So this is 60. That would be 30. But we've already got this other one in radians. So what's 60 in radians? That's pi over 3. So now I've got the answer for each of the two inverse problems. But now I want to subtract the 2. So pi over 2 minus pi over 3. If you go ahead and get a common denominator, that's going to end up being pi over 6. Okay. So now this answer becomes the input for that outside function. So I'm really wanting to take care of tangent of pi over 6 now. So is my final answer going to be a ratio or an angle measure?
Ratio.
Okay. It's got to be a ratio because we're just simplifying a normal trig function. The answer is only an angle if you're simplifying an inverse trig function. Okay, and this actually goes right back to your happy minutes. So pi over 6 is in the first quadrant. So pi over 6 is actually 30 degrees. Create a right triangle. This one would be 60. So across from 30, remember, is always 1/2. Across from 60, square root of 3 over 2. And then the hypotenuse is 1. But what does tangent want? He always wants the opposite, 1/2 over the adjacent square root of 3 over 2. And what happens when you divide by a fraction? Okay, so I'm going to flip this guy up. So 1/2 times 2 over the square root of 3. The 2's are going to cancel. I have to rationalize it. So I should end up with square root of 3 over 3 for my final answer. Okay, who asked me about that one originally? Raphael? Does that make sense? Okay. I would say if it wasn't number 5, it was number 7 that caused people some issues. Okay, the most conversations I heard was really about number 7 because there were people on both sides. It's no solution. No, it can't be no solution. I don't remember if I heard that in here. I definitely heard it in the first period. Was it in here as well? Okay. I don't remember. What did you guys ultimately put? Okay, pi did turn out to be the right answer. Okay. Was there anything else we wanted to talk about? 11. Okay. So let's see here. Now, in order to graph secant, I showed you to do that by graphing its reciprocal. So I want to graph cosine. -2 cosine of 2x plus pi over 2 plus 1. So with my compound inequality and the fact that it's cosine, we're going to put that between 0 and 2 pi. In fact, what am I going to put between those?
2x plus
2x plus pi over 2. Let me give myself a little room here. 2x plus pi over 2. All right, so if I subtract the pi over 2, that is a negative pi over 2 less than or equal to 2x, less than or equal to 3 pi over 2, 2 pi minus pi over 2. And then we want to divide through by 2, so negative pi over 4 less than or equal to x, less than or equal to 3 pi over 4. Okay. So I know I'm going to go ahead and pair up the lower boundary with whatever the first critical turns up to be, the upper boundary with the last critical. And speaking of, let's talk about the critical. Now we're trying to graph cosine. So does cosine start with a 0 or a maximum? He always starts with a max. Remember, his was 1, 0, -1, then 0, then 1, right back up to a maximum to finish off the period. Is there anything outside the parentheses that'll affect these 5? Okay, what am I doing to them? I'm going to multiply each of them by -2 and then add 1. So 1 times -2 plus 1. -1. And then 0 times -2 plus 1. Then we have -1 times -2, 2 plus 1. There's a 3. Let's see, the 0 will give me 1, and the 1 will give me negative 1. Okay. Is everybody okay so far? How do I finish filling in the table, though? Okay. So how far is it from a negative pi over 4? Here's negative pi over 4 to a 3 pi over 4. Yeah, it's just pi, right? And you can solve that algebraically as well. But once you find that difference, you always, what? Divide by 4. Okay. So that's what I'm going to add over and over again. So let's see. Negative pi over 4 plus pi over 4. 0. Plus pi over 4. Plus pi over 4 plus pi over 4 would be 2 pi over 4. So that's pi over 2. Plus another pi over 4 does give me 3 pi over 4. Okay. So this is going to represent one period of negative 2 cosine 2x plus pi over 2 plus 1. So negative pi over 4, negative 1. Let me go ahead and get these out here. Then we have 0, 1. Then we got pi over 4, 3. And then we got pi over 2, 1. And then we've got 3 pi over 4, negative 1. Okay. So I'm going to go ahead and repeat that pattern just over and over again. So the next one would be a 0, maximum, 0, minimum. I'm not going to do the same thing over here. 0, max, 0, min, 0, max. Okay. Now, what do I have right here? What did I just draw? That's the midline. So we talked about whenever your graph shifts vertically, it's wherever it crosses the midline, that's where your asymptotes are going to be. Okay, so I would have an asymptote here, here, here. So I'm going to have several asymptotes on this graph. Now you'll notice the cosine function would curve through these points, but I ultimately want secant. So what am I going to do at every maximum and minimum? There you go. It's going to go with the asymptotes. They're going to look like what? They're going to look like parabolas. So every maximum will have one of those branches opening up. Every minimum will have one of those opening down. So see, I got all my information from negative 2 cosine 2x plus pi over 2 plus 1, but I used that to get the negative 2 secant graph that I wanted. And then, of course, we can see the midline is y equals 1. The amplitude is the absolute value of a, so that's 2. The period is 2 pi divided by b, so 2 pi over 2 is pi. What's the frequency? Yeah, 1 over pi. It's always the reciprocal of the period. So this is telling me that it should repeat one time in pi radians. And remember, for this, for secant and cosecant, one period consists of an upward and a downward opening branch. And there we go. Dylan, you asked about this one, right? Was there something specific about it, or? Oh, you tried to graph it from, yeah. This one, I didn't have any points tied to that, but I did have the points tied to the table, because those are going with the reciprocal. Okay, anything else? Okay. So this is a short week. You guys had yesterday off, and I'm not going to be here on Friday. Remember, on Friday, you've got your homework to work on. You also have the review you can go ahead and start to look at. So you're going to have, a good amount to do. You shouldn't have nothing to do on that day. But that means there's no tutorials on Friday as well, because I'm not going to be here. But if you are wanting to retake, and I want to say overall I had 3 or 4 people fail the test. Okay, so there were unfortunately some people who failed. If you do want to go ahead and retake that, you have until Monday morning by 8:05 if you want to retake it. Just because this is a short week, I'll go ahead and let you do it by Monday morning. Okay, good. Let me make sure this is good to go. Okay. Well, one other thing before we go ahead and get started, the last time I actually spoke to you guys during the class period was on Thursday when we did this Chromebook activity. And I think that actually turned out really well. It was really not, hopefully you like the activity. Would you like to do more things like that, or you would like to? Okay. But I did go ahead and tell you that on Tuesday, if there were any questions, these are all the expressions that you came across on Thursday. Was there any one or a couple that was causing you problems? You'll notice some of these were going to be really quick. Like, for example, what's 1 over sine? That's cosecant of theta. What's cosine of negative theta? That's just cosine of theta. Because remember, what kind of function is cosine? Is he even or odd? He's even, okay? If he was odd, then you could pull the negative out in front, okay? Cosine over sine was cotangent. 1 over cosecant was sine. And then the rest of them, depending on the method you used, maybe you had to do a little bit of work. Okay, and I believe I showed you this one in class, that one. I showed you how I worked it. I gave you a hint on the 1 plus tangent, 1 plus cotangent. Okay, but are there any problems specifically you guys want to take a look at? No, Rhett? 1 plus tangent or 1 plus cotangent? Okay. I kind of thought that some people would actually do that, so I came in this morning and I worked it out using the conjugate, like I showed you the other day, that hint that I gave you. Now, again, does that mean that working it by the the conjugate was the only way to do it? No, we've seen several times there's going to be different ways to simplify these problems. So while I have this one already taken care of using the conjugate, would anybody like me to work the same problem just by changing everything to sine and cosine? Or are you guys okay with that? You want me to do that? Okay. So does anybody have any questions on this? Okay, so that fraction just works down to tangent. So let's see if I'm able to get tangent by doing this. 1 plus tangent of x over 1 plus cotangent of x. So the final answer should be tangent of x. So let's see how we get there. So let's just rewrite everything in terms of sine and cosine. In fact, what is tangent? So that's 1 plus sine over cosine. So that's a quotient identity or ratio. Cotangent is the reciprocal. So that would be cosine of x over sine of x. Okay. Now, before I can look at the whole, I've got to take care of the numerator and the denominators. So I'm going to need to change these. This would be cosine over cosine. This one would be sine over sine. Because what is cosine divided by cosine? It's still 1. Same thing for sine over sine, but writing it this way, I now have a common what? Common denominator. Okay, so let's pull everything together. So up top, this would be cosine plus sine over cosine. On the bottom, then you've got sine plus cosine all over sine. And we've always seen this, quite a few times. If you're dividing by a fraction, multiply by the reciprocal. So this would be cosine plus sine over cosine times. Now let's take the reciprocal of that. So I'm going to have sine over sine plus the cosine. And do you notice anything? There you go. These are the same groups, cosine plus sine, so the binomial factor cancels. And what is sine divided by cosine? It is tangent. Okay. So did this way actually turn out to be a better way than the conjugate method? Yes, but knowing the conjugate method is still very valuable. Okay. That's why I went ahead and gave it to you that way first. All right. Because there is an example coming up where I would recommend not rewriting it in terms of sine and cosine, because that actually gives you more work. And you'll see what I mean in just a second. Okay. Any others? Oh, that is the 1 plus tangent 1. There we go. Hey. Hold on. We should have time before the bell rings. So any other questions on the activity from Thursday? Okay. If you do have any questions, just let me know. In fact, this one, I have him marked out, the cosine of theta plus 3 pi over 2. That one is actually done better graphically than using the trig identities. So that's why you didn't see him as part of your activity that day. I just went ahead and took him off there. Okay. All right, back to this. Okay, we are almost done. We've only got 4 left, so we'll go ahead and do this one today, and then I'm going to go ahead and give you a little bit of time at the end of class period to take care of something for me. But we have secant of x over 1 minus secant of x minus secant of x over 1 plus secant of x. Now, let's go ahead and simplify this where there are no fractions. So we should get down to a single trig function. Now, not like the activity, there may be some kind of operation applied to the trig function, but one trig function is what our ultimate goal is. Okay? So if you have 2 fractions like this, the first thing I would say, go ahead and get a common denominator. Can you tell me, what do you think that common denominator would be? I need a common denominator for 1 minus secant and 1 plus secant. And what can you always do that will give you a common denominator? Yeah, just multiply them together. So a product of the 2 you have is what we're looking for. 1 minus secant of x times 1 plus secant of x. So I want to make sure that both denominators look just like that. Okay, once we get that done, then I can combine them into a single fraction, and we go on from there. There's only one thing you could do here, and it really doesn't have any overall change to the problem. You'll notice, is this a monomial, a binomial, or a trinomial? What kind of polynomial is this? Raphael, what do you think? This is a binomial, okay? The fractions are your individual terms. Remember, they're always separated by addition and subtraction. So this is a binomial. So you'll notice with both of those numerators being the same, we actually do have a GCF. Now, we can go ahead and factor secant of x out, and then go ahead and solve it, combine the 2 fractions into one, bless you, and then pull the secant back in. It just makes it a little easier. You only have to deal with 1 instead of secant, or we could just go ahead and leave him in there and just go ahead and combine those fractions. First period decided to pull secant out. Second period decided to leave secant in. What would you guys like to do? And like I said, it does not change the result. Either way, we're going to be able to get to the answer. What do you think, man? Would you like to pull out the secant or no? She does not. Okay, so we are leaving the secant right there where he is. Now, if you want to pull out the secant, work along with us, and what should be happening? You should be able to get to the same answer. Okay, so I'm going to start with this first fraction right here. So we have secant of x over 1 minus secant of x. So I've got this binomial, but I want it to look like that product of binomials. So I'm going to multiply by what I'm missing. 1 plus secant of x. Okay. And then we have the minus right here. So let me ask you, what happens if you divide some value by itself? What do you get? Yeah, you get 1. So 1 plus secant divided by 1 plus secant is just 1, right? See, here's the thing. I don't want to change the value of this fraction. Okay, I just want to change the way he looks so that I can perform this operation. That's what we're doing. We're creating what's called an equivalent fraction. Now I'm going to do the same thing over here. The second fraction is secant of x over 1 plus secant of x. Well, this one, he's missing the 1 minus secant of x. Okay. Now, let's go ahead and multiply these 2 products together. So somebody help me out over here. I need to take secant and distribute it across 1 plus secant. What did that give me? Okay, so Dylan says secant plus secant squared. Perfect. Okay. over. Now, why don't we go ahead and multiply those denominators together? I need to multiply 1 minus secant times 1 plus secant. Well, they are conjugates, right? What's going to happen if I multiply conjugates? What kind of expression will I get? Do you guys remember from factoring? Starts with a D. Difference of squares. But let's say you don't remember that. If I have two binomials and I want to multiply them, what's the strategy? What's that acronym? FOIL. What's that stand for? Okay, so first outside, inside, last. So let's go ahead and multiply this. First, what's 1 times 1? 1. Now let's multiply the outside. 1 times secant. So secant, that's plus. Now I'm going to multiply the inside. So negative secant times 1. Negative secant. And then the last. Negative secant times secant. Negative secant squared. Now, if they are conjugates, your outside and your inside terms should always cancel. See, there's secant minus secant, so those gone. So all I have left is 1 minus secant squared. Okay. So that's my common denominator. 1 minus secant squared. Now minus, okay, the big minus right here. Now I'm going to do the same thing over here. But what's secant times 1 minus secant? So that'd be secant of x minus secant squared of x. And again, if I multiply those two binomials, I'm going to get that common denominator. 1 minus secant squared of x. There we go. How's everybody doing? Okay. So these are my two equivalent fractions. We have the same denominator. Now let's go ahead and pull them together. But this is where a lot of students make their mistake. If you're subtracting, what do I have to do with that negative? I've got to distribute. So let's see. This is all going to be over the 1 minus secant squared of x. So these two are going to stay the same. I'm going to have secant of x plus secant squared of x. So this is going to be minus secant minus a negative secant squared. So plus secant squared of x. Now, did we notice anything? Okay, so secant minus secant, got a pair that canceled. But what's secant squared plus secant squared? So this is 2 secant squared. Remember, just think of the trig function as a variable. Now, let's also go ahead and do one other thing. I wanted to multiply those two binomials together in the common denominator because I knew something was going to happen. What is 1 minus secant squared equal to? Okay, what's that done? Oh, we're so close. There we go. The identity is 1 plus tangent squared is equal to secant squared, right? So if I subtract the secant squared over to get the 1 minus secant squared that we have, I've got to subtract the tangent squared over to see what it's going to complete that equation. And it will be negative. Okay. So this is negative tangent squared of x. Okay, so the good news, I've got one fraction and only two trig functions. Remember, we want to go ahead and rewrite this so there are no fractions and there should only be one trig function. So what would we do from here? Anybody have an idea? What's a strategy that people really like so far? I'd go ahead and convert everything to sine and cosine. Now here's the thing. 2 secant squared, okay, so 2 secant squared of x is the same as 2 times 1 over, what's the reciprocal? Cosine squared of x, right? So I'm going to multiply those together. So I'm going to have 2 over cosine squared of x, all divided by. Now, tangent is sine over cosine, right? So what would negative tangent squared be? Well, it's still in the denominator. We haven't flipped it yet. So it's still going to be sine over cosine. but both of them are going to be squared, and we don't want to forget the negative. Okay, so tangent is sine over cosine. Tangent squared is sine squared over cosine squared. And now you probably see where we're headed with this. What would I do? Multiply by the reciprocal. Flip that up. So this is 2 over cosine squared of x times, we have negative cosine squared of x over sine squared of x. Well, what's multiplying by the reciprocal going to do to help me? Those cosine squareds are now gone. So I've got negative 2 over sine squared of x. But remember I said I didn't want any fractions. So we are to our last step. Can anybody tell me what the answer is? I don't want a fraction. So I have sine. Okay. Okay, so Christian says it has to be multiplied by negative 2. So what would that be? Cosine? He says negative 2 cosecant squared. And he is right. Now, if you're not sure how I went from that last step to the answer, if you have a fraction, you can actually pull the numerator away from the fraction, but it's still going to be joined by multiplication. So if I were to show a side step here, you could have negative 2 times 1 over sine squared of x. And the reciprocal of 1 over sine squared is where we got the cosecant squared. And see, the negative 2 just multiplies right against it. Okay. How are we doing? Good? Okay. All right. Now, I will go ahead and tell you, I'm not going to go ahead and show you, I will show it to you in just a second, but in order to show you, I would have to go ahead and turn on the document camera, and I am not a tech-savvy person, so for some reason, when I do that, the recording crashes. So I'm going to go ahead and show you that after I go ahead and start, because a question is there any way to work this one faster? And I actually think of the 2 ways I sat down and found, this is actually the faster way. Because I did work the problem where I turned every one of those secants into 1 over cosine. And then I went from there. But I'll show you that in just a second. So while it's a great strategy, there are times when that's probably not the way you want to go. All right, so here's what I'm going to do. We're going to wrap up the notes tomorrow. But you see this second problem right here? 1 plus cosine over sine plus sine over 1 plus cosine. Okay, I'm going to give you the rest of the period to go ahead and try this one on your own. See if you can rewrite it, no fractions, get down to a single trig function. Because tomorrow when you come in, I'm going to have the random number generator up, and some lucky person is going to come on up and show me how to solve this problem. Now, I'm going to help you by getting you in the right direction. I would, again, use a common denominator. Can anybody tell me what the common denominator would be? Okay, Satish, what do you think? He's absolutely right. The common denominator would be sine of x times 1 plus cosine of x. Now, I want to talk about that for just a quick second. In the previous example, did I multiply the 2 together? The 1 plus secant and the 1 minus secant? I did, because I knew what was going to happen. When I multiplied them together, see, it gave me an identity that I could use to help simplify the problem, right? Now, if I were to do that here, sine times 1 plus cosine, well, that's just going to be sine of x plus sine of x cosine of x. Does that look like any of my identities? Okay. So here's something that I learned just from experience. When I'm working these types of problems, if I'm looking for a common denominator, if I can multiply those and come up with some kind of identity, I go ahead and do so. But if I multiply them together and that doesn't do anything to help me, I go ahead and leave them separate. And on this one, you're probably going to want to leave them separate for what's going to happen. Okay. Now, if you do want to check your answer with me before you leave, okay, that's perfectly fine. But go ahead and take your time. We still have a decent amount of time, just under 10 minutes, to go ahead and take a look at this problem. And then tomorrow we'll come in, hopefully wrap this up, and then, we'll just continue. Thursday will be averages and working on the homework. Okay. Questions? Okay, well, let me go ahead and stop the recording.